All right, geometry crew. Today we are doing angle measures and segment lengths, section 12.4. And there's just a nice pattern that you can observe while looking at the equations for this section. All right. So, for instance, when you're trying to find segment lengths using tangents or secants or chords, if you have two chords that are intersecting inside of a circle, all right, just remember you can just multiply A times B, all right, the two segments that are broken up on the one chord, and set it equal to C times D, the other two segments that are broken up on the other chord. All right, now, when they're intersecting outside of the circle, all right, so you have two secants here that are intersecting outside of the circle. It's always the outside segment plus the inside segment multiplied by the outside segment. All right, so it's outside plus inside multiplied by the outside. And it's the same thing here. Set it equal to outside plus inside multiplied by outside. And then when you have a tangent and a secant, you take outside plus inside times outside, which is what we just did, but then with the tangent, you just square it. So it would be y plus z times y equals t squared, okay? So that's when you have segment lengths. That's when you're trying to figure out segment lengths. And then when you're trying to figure out arcs and angles, all right, so if you have two arcs, all right, notice that they're formed with these vertical angles here, okay? And the intersection of the secants is inside, all right? You just do x, this arc, plus y, which is this arc, and then multiply by 1/2. All right, now, there's three different ways that they can intersect outside. They can intersect outside with two secants, and then we're solving for this angle, number 1. So what you do is the larger arc minus the smaller arc times 1/2. Okay? Here you can have a tangent and a secant. Once again, it's larger arc minus smaller arc times 1/2. And then in this case, you have two tangents, all right? But you would just do the larger arc minus the smaller arc times 1/2. All right, so you need to remember these things when we're doing these problems. And I'm just going to do these first 4 problems for you or on page 794. All right, and I'm going to try to draw this picture. Let's get a blue pen so it'll look similar to all right, so we have our circle, and then we have a tangent coming off, and this goes straight through the circle. So we have a tangent and a secant, and they label this Z. All right, that segment is Z. This is 6. All right, and then we have another chord like that. They tell us this is 10. This is X. This angle here is Y degrees. This is 6. This is 9. This is 45 degrees, this arc. And this is 85 degrees, that arc over there. I think I have everything labeled. So they're just going to ask us questions about this. All right. And the first question, number 1, all right, it says, what is the value of X? Well, remember, this is a segment. So we have to use our segments. And notice it's the intersection inside of the circle. So the theorem that we're using here is this one, number 1. Okay? A times B is equal to C times D. So I'm just going to do that. Okay? So x times 10, all right, is 10x. Then we have 9 times 6, all right, which is 54. And we just divide both sides by 10. So x is equal to 5.4. All right, let's look at number 2. Number 2 says, what is the value of y? All right, so y, we are solving for an angle measure, okay? And notice that the intersection is happening inside of the circle, okay? So we're going to be using this theorem, all right? Theorem 1213, the first one. So it's x plus y, the two arcs, all right? And then divided by 2. So here is the angle that we're solving for. We need to add the two arcs that are being cut off, 85 and 45. So it's 1/2 times 85 plus 45. All right. Now remember, it's 85 plus 45. We're adding the two arcs because the intersection is inside of the circle. Remember, if the intersection happens outside of the circle, then you subtract the arcs and divide by 2. All right? So we have 1/2 times 130. So y is equal to 65 degrees, which is also going to equal this angle because it's a vertical angle. All right, number 3 says, what is the value of z? All right, once again, we have a side length, all right, or a segment length with tangent and secant. So if I look at my tangent and secant is this one right here. So remember, it's always outside plus inside times outside is equal to t squared. All right, so if we look at our diagram here, it'll be 6 plus, so this is outside plus inside, which is 9 and the 6, which is 15. So we have 6 plus 15 times the outside, which is 6. And that's equal to z squared. All right? So we do 6 plus 15. Remember, you always do what's inside of the parentheses first, order of operations. And then we have 21 times 6 is 126. In order to get rid of that square, take the square root. So the square root of 126, about 11.2. So z is equal to 11.2. All right. Now let's do number 4. Number 4, they don't give us a diagram, so we just have to figure this out on our own. All right. I would draw a diagram. So for number 4, it says the measure of an angle formed by two tangents to a circle. So two tangents to a circle it's going to look like that, and they say is 80 degrees. What is the measures of the intercepted arcs? So they want us to say this arc and this arc. Right? So we know that the distance all the way around a circle is 360 degrees. All right? So if we call this x right here, all right, then this is going to be 360 minus x. All right. Now let's take a look. We have angle measures, so and arc measurements. So the theorem that we should be using is this one. All right. Two tangents to a circle. So we take the larger arc minus the smaller arc, divide by 2, or multiply by 1/2. All right. So let's take a look here. Larger arc, which is 360 minus x. We subtract the smaller arc, okay? Multiply by 1/2, this is equal to 80, right? So we have 1/2, 360 minus 2x is equal to 80. So we get 180, because 1/2 times 360 is 180. 1/2 times a negative 2x is just that. So I'm going to add x to both sides. I don't want it to be negative. And I'm going to subtract 80. All right, so we have 100 is equal to x. So if this arc here is x, I know the red arc is 100, which means the blue arc over here is 260. All right. So there's a few problems that'll help you through this section. Make sure you read through the section. It'll definitely help. Make sure you look at the formulas and do these problems. They're really not that difficult. All right. Hopefully everybody's staying healthy.